Finding horizontal asymptotes of a function, for one thing, horizontal asymptotes, and for that matter, vertical asymptotes, can only exist in rational functions. So if you have just a polynomial function, no fractions, then guess what? You're in luck. No asymptotes. But here we do have two rational functions, so we can find asymptotes. To find the asymptotes, the horizontal asymptotes, we need to take the limit as x approaches infinity of our function. Now, if you remember back to when we dealt with limits at infinity back in Unit 3, to evaluate a limit as x approaches infinity, we need to take every term in that function, divide it by the highest exponent of x, so that would be x squared. Like so. And what happens is the 6x squared over x squared will reduce out. The others will not. So reducing what we can, leaves us here. Now plugging in infinity, we'll have 3 divided by infinity squared, which in the past we said was close enough to 0. We would call 0. Anything that has an x left in the bottom is essentially 0. So really what we have is 6 over 2, meaning our horizontal asymptote, being a line, needs to have an equation, y equals 3. It's a horizontal line, so it's a y equals type of line. So this function has a horizontal asymptote at y equals 3. So we'll do the same thing on question B. We'll take the limit as x approaches infinity of this function, divide by the highest power of x, which is again x squared. We'll reduce what we can. We have 2 over x on top, and 1 plus 1 over x squared on the bottom. Substitute in the infinity. Anything that has an x left in the bottom goes to 0, so we have 0 on top, 1 on the bottom. Horizontal asymptote at y equals 0.